let's start by doing exactly what we did yesterday and first find the x-intercepts. There we go. Let's first find the x-intercepts. Okay. So we have our two parentheses, right? And we said, well, if we're multiplying here and they're equaling 0, that means one of these two, x minus 3 must equal 0, or x minus 7 must equal 0. So we're finding a number basically that when you plug into any parenthesis, you get 0. So for here we have x minus 3 equals 0, therefore x equals 3. So there's one of my x-intercepts, which is 3, 0. Right? Squiggly line. And here we have the other one, x minus 7. So when x minus 7 equals 0, x equals positive 7. So that's how we got those two yesterday. Only you had to factor them all. Okay, so 7, 0. And the next question is, well, how do you get the vertex? Right? How do you get this point right here? Okay. So just as we looked up on the board earlier, we said, well, this point is in the exact middle of these two, right? Which we know are 3 and 7. So for the vertex, I can start off by finding the x-coordinate, which is just going to be my two values that I just got from my intercepts. You know, these two answers right here. If I find the halfway point by adding them up and dividing by 2, that will give me the middle. If I add 3 and 7 and divide by 2, that'll be 10 divided by 2, right? And 10 divided by 2 is 5, which means the x-coordinate of my vertex right here, we know, is 5. That's how far we are along. Step 1, get the two intercepts. Step 2, find the middle of those 2 points. Right? Now, step 3 is to find out, well, what's the y-coordinate here? Okay? So we have the equation, right? So what I'm going to do is find out, well, what is the y value when the x equals 5? So we take whatever answer we get from here, in this case it was 5, and we're going to evaluate it at that number. We have minus 3, minus 7, and I'm going to be evaluating 5. And remember this notation over here, this left-hand side is just a reminder. We don't actually calculate anything with the f of 5. This is a reminder at the end of the problem, when we get the answer on the other side, what we use to get that answer. So if we go through and simplify here, right, we'll get 5 minus 3, which is 2. Right? And we'll get 5 minus 7, which is negative 2, right? And 2 times negative 2 is negative 4. So that's its value, negative 4. Okay. So we'll take whatever we get from this step is going to be our y-coordinate of the vertex. Okay. And whatever we get from the second step here, that's our x-coordinate of our vertex. And this notation, why do we have this notation right here, this f with the parentheses and 5? That's just a reminder so that at the end of the problem, I can actually see, how did I get a negative 4? Oh, I plugged in 5. So you have your x value and your y value right here. These numbers will match. The number you have here will always be this number. The number you get as your answer will be the y value. So we like this format because it's a good reminder of what our full answer is. Okay. Not too bad, right? And there's one more thing we're not going to look at quite yet that we'll use to help us graph. Okay, and if I can find it right here, And that's the y-intercept. There's one more point, which is negative 90 that we saw in the last problem, which is just that number on the end. So we'll use that later on as well. Okay. But for now, we'll just stick with those 3 points, okay, and get a more accurate graph. So at least this thing is, we know where this vertex is going to stop. We're not going to sketch this and it's going to go way down or it's going to be really far too short. We know exactly where it's going to be from now on. Okay. All right, so let's just practice a few more together, and as soon as you get the hang of it, feel free to go ahead and try on your own. Also, remember you do have, let's back up, you do have decimals, okay? So if you wanted to clear those, you hit that little X here, and that clears them out. You could type everything in, X minus 3. X minus 7, okay, and then look at the full graph, right? And you'll see, well, I got 3 and 7 here, okay, that's what I got, 3 and 7, so I'm good there. And then go down to your vertex, 5 comma negative 4, there it is, 5 comma negative 4, so you get this sense as you're going along that you are getting the right answer. And of course, if it doesn't match, don't just change your writing and put the right answer and say, okay, let's do the next one. Go back and find out, what you got wrong. So chances are, if you didn't get it right, you just missed some arithmetic thing here, or just multiplied wrong, or some small thing that's really easy to fix. Okay? But of course, if you don't fix it, you keep making the same mistake. Okay? All right, so that's how I want you to use this tool and to help you. And at some point, you'll keep on getting the graphs to match, and you won't even need it anymore. You'll have some confidence that you don't need that anymore. Okay, so let's just try a few more. Go to number 2, and look at these 2 equations. What's different about the 2 functions? Yeah, so this one has a GCF of 2. So we're going to see, well, what happens to the graph if we just add a GCF? The same exact x-intercept, right? But the GCF is there. So we're going to look at the effect of a GCF on the vertex. So let's do the same thing just for the sake of being consistent here. Let's find the x-intercept. Okay. And as we did yesterday, we ignore the GCF when we're doing the x-intercept. So it's really the same exact thing. X minus 3 equals 0. Right, just like over here, x minus 3 equals 0, because they're the same exact parentheses, right? So they're going to be identical here. So all this work will be exactly the same. And x minus 7, 0. So we get 2 roots, x equals 3, and x equals 7. 3 comma 0, and 7 comma 0. Right, nothing changed. We just see, though, the vertex, though, definitely has moved further down. Okay. The x-coordinate of the vertex, all right? Well, since the x-intercepts, that's where these values came from. Like, where did 3 and 7 came from these right here, so that's going to be the same, right? X will equal 3 plus 7 divided by 2, which still equals 5. That has not changed either. Okay. So this is still 5 comma something. So far, the effect of a GCF has not changed our x-intercepts. It has not changed where the x-coordinate of the vertex is, because it's always going to be in the middle, right? Exactly in the middle. Now, let's find out, evaluate this at 5, just like we did here, but now there is a 2 in the front. So it's 2 times 5 minus 3, right? 2 times 5 minus 3, and then times 5 minus 7. So you might be able to predict already what's going to happen. We're going to have, before we just had 2 times negative 2, right? We had 5 minus 3, which was 2, and the 5 minus 7 gave us negative 2. But now we have another 2, the GCF. So instead of negative 4, now we have 2 times negative 2, which is negative 8. So that GCF had an effect on how far down that vertex goes. So the larger this GCF the number is, the more this thing's going to swing down before it comes back up. And if we had like a decimal, if we had like 0.5, you can imagine if it's 0.5, it would just kind of go only halfway, right? Instead of at -4, it would be at -2 if the GCF was a half. So it just changes how far down or how far up that vertex goes. Okay. Are there any others on the front of here that we want to look at? Anything else that looks different from what we've already done? 3 and 4 look kind of the same as 1 and 2. What about 5 and 6? Do those look the same? Something's different about them. What direction are they opening? Yeah, they're opening down. These are all opening up. Do you want to do something where they're opening down, or do you think you got it? You got it? Okay, I'll let you guys try it out. All right, and then we got here. Are we okay with these? Same thing. Right. Now we get down to 9 and 10, 11, 12, and there's no graph there already. So kind of like yesterday, you'll just have to sketch it in yourself using the numbers, right? Now you can go back to Desmos and help yourself out, but do this as a check. Obviously, don't get to a blank problem and just type in the equations and see what the graph looks like. You want to try to get this graph, with no help and see how close you come. And then as you practice with it, you'll get better and better and better. Okay? So that's what it's for, just a tool. Okay. All right. So I'll let you guys go ahead and practice. I recommend teaming up maybe for the front side, and then when you get to the back side, try them more on your own, and then maybe check Desmos if you feel like you need to make sure you're doing it right. Okay. But it will give you the exact, a way telling for sure that you're getting the right points here. So you can click on it and know your 2 points are correct and your vertex is correct as you go along. All right. So you guys can go ahead and get to work on that right now.